All right, this is 12.6b volume of spheres. We talked about what a sphere is in 12.6a, so you already know what it is. Now we're going to talk about volume as opposed to surface area. To find the volume of a sphere, a good way to find the formula is to think of it as a bunch of little pyramids pushed together, meeting at their vertex. So what we can do now is think of those pyramids. Well, the volume of a pyramid formula is 1/3 area of the base times the height of the pyramid. Well, now we just got to think of how many there are. Let's call that number n. So if we take n, the number of pyramids, and multiply by the volume of each pyramid, that'll give me the volume of the sphere. So now let's see if we can regroup these factors and somehow come up with a good formula that works for sphere. Well, the height of the pyramid is the what of the sphere. If you said radius, you'd be correct. The area of the base of the pyramid times the number of pyramids is the what of the sphere. If you said the surface area of the sphere, you'd be correct, because the area of each little base is each little square here. And if I cover them with n, if there's n pyramids, well, the surface area will become the number of bases times the area of the base. So the surface area of a sphere, hopefully you remember, is 4 pi r squared. And now we just have the third. So now I'm just going to regroup this again. I'm going to take the 1/3 times 4, which is 4/3. I got my pi. And then I have radius squared times the radius. That's the radius cubed. And voila, we've got the volume of a sphere formula, 4/3 pi r cubed. So that's a good way of thinking of how the formula comes to be. And now you just need to know that formula, 4/3 pi r cubed. It's not the nicest, but it's the way it works. All right. So let's go give it a shot. 4/3 pi r cubed. If the diameter is 9, find the volume. Well, volume equals 4/3 times pi times the radius, which is half the diameter, of course, cubed. So we're going to do 4.5 cubed times 4/3. So the third times 4/3. And I'm getting, let's see, 121 and a half. 121.5. And that's inches cubed. There you go. Very simple. Once you know the formula, let's just plug into the formula. And then a hemisphere. Well, a hemisphere is a half a sphere. And while with surface area, if you recall, when we split the sphere in half, there was a new surface we had to consider. When we're talking about space inside, the volume of a hemisphere is just literally half the volume of a sphere. So we're going to take a half of 4/3 pi r cubed, which is just 2/3 pi r cubed. So you can use that formula for a hemisphere. To find the volume of this composite solid, I'm going to do my cylinder minus my hemisphere, and that's volume of the cylinder minus volume of the hemisphere. So I'm going to take area of the base times the height on the cylinder minus 2/3 pi r cubed. Since the radius is 2, it's going to be 4 pi times the height of 2 minus 2/3 pi times 2 cubed. And then that's 8 pi minus 2/3 of 8 pi. And 2/3 of 8 is 16/3. So I'm doing 8 pi minus 16 pi over 3. And then I can make this into 24 pi over 3 minus 16 pi over 3, which is 8 pi over 3 cubic inches. And that's really it. 4/3 pi r cubed for a sphere volume, 2/3 pi r cubed for a hemisphere volume. Go do the homework.